Welcome back everyone to day 2 of hyperbolas. So now that we know the standard form for the equation of a hyperbola and how to get information from that standard form and then graph it, we're going to work backward. I'm going to give you certain information. You're going to figure out what the values of A, B, C, and the center are, and then write the equation. So as you can see, there are graphs over here on the right hand side. Those aren't required, but they're often helpful to help you graph these. So let's get started. So it says write the equation in standard form for each hyperbola. This particular hyperbola has focal points at plus minus 5, 0. So if we were to graph those 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So what we know right away is that the center of the hyperbola is at 0, 0 because the center is halfway between the two focal points, and the focal points lie on the transverse axis. The endpoints of the transverse axis are plus or minus 3, so we know that A is equal to 3 because that's the distance from the center to the endpoints of the transverse axis. And we already know that C is 5, so we can figure out B because A squared plus B squared is equal to C squared, so B is equal to 4. And we know that this hyperbola is going to open left-right, so just a rough sketch of that in there. It's going to look something like that. So the equation for our hyperbola, x minus 0 quantity squared over a squared, so 9, minus y minus 0 quantity squared over b squared, which is 16, is equal to 1. So what I'd like you to do right now is I'd like you to pause the video, answer letter B, and then hit play to check your answer. All right, so you can see that looking at the information about the focal points, they are 14 units from each other, which means that the center is located right in the middle of that, which would be at the origin 0, 0. And so we know that C is equal to 7. The ends of the transverse axis, those are the points on the hyperbola, are 4 units away from the center, so A is 4. And using the Pythagorean theorem, C squared is equal to A squared plus B squared. So if C squared is 49 and A squared is 16, B squared has to be 33, so B is equal to the square root of 33. And this hyperbola opens up down. So the equation is going to be y squared over 16 minus x squared over 33 is equal to 1. So we'll try another one like this. Information is given in a slightly different format. So focal points at 0 plus or minus 6. So that hyperbola is going to open up down. Let's see, 1, 2, 3, 4, 5, 6. So right there's a focal point. Let's use open circles for focal points. And there's another focal point over here. And so the center is right there at 0, 0. Transverse axis length is 6. So that means that A is 3. So the points on the hyperbola are 3 units away from the center, and the hyperbola is going to open up down like that really rough sketch of that. So what do we know? We know center at 0, 0. We know that A is equal to 3. We know that we know that C is equal to 6. And we know that A squared plus B squared is equal to C squared. So what number do I have to add to 9 to get 36? I have to add 7, so B is equal to the square root of 27. So our hyperbola, which opens up, is going to have a positive y term, so y squared over 9 minus x squared over 27 is equal to 1. I would like you to do the next problem. Pause the video, do the next problem, and then when you're ready, hit play to check your answer. All right, so we know that based on the location of the points on the transverse axis that our hyperbola opens left and right. The center is at the origin, so A, the distance from the center to an endpoint of the transverse axis is 4, B is 3, and C is 5 by the Pythagorean theorem, because A squared plus B squared has to be equal to C squared. The center is at 0, 0, it opens left, right. The x term has to be positive because it opens left, right, so we have x squared over a squared, or x squared over 16, minus y squared over b squared, which is y squared over 9, is equal to 1. All right, now we're going to move on to writing the equations of a few hyperbolas whose centers are not located at the origin. So we're going to use the graph to help us with this a little bit. The endpoints of the transverse axis are -2, -3. So -2, -3, there's a point right there. -2, +7, so 2, 4, 6, 7 right there. And we know that the center is going to be halfway between those two. So we know we've got a center at -2, +2. We also know that the distance from the center to one of those endpoints of the transverse axis is the value of A, so 1, 2, 3, 4, 5. So we know A is equal to 5, which you could figure out by finding the distance between the two y coordinates, which is 10, and dividing by 2. And the endpoints of the conjugate axis are -4, +2, which are going to be there, and 0, 2, which are going to be there. So you can tell by inspection that B is equal to 2. You could also tell that by taking the difference in the x coordinates, which is 4, and dividing that by 2. So C, remember, C squared is equal to A squared plus B squared, so C squared is 29, and C is equal to the square root of 29. Our hyperbola opens up, down. We know that because of the location of the endpoints of the transverse axis. And so our y term is going to be positive. So our equation is like this: y minus 2 quantity squared over a squared, which is going to be 25, minus x minus -2, which is going to be x plus 2 quantity squared, over b squared, which is 4, is equal to 1. I'd like you to pause the video now and try letter F on your own, and then when you are finished, hit play to check your answer. All right, after locating the endpoints of the transverse axis on the graph and locating the center, we can tell that this hyperbola opens left-right. The value of A is 4, B is 3, and therefore C would be equal to 5. The center is located at -1, +2, and since it opens left-right, the x term is going to be positive. So x minus -1, or x plus 1 quantity squared over 16, minus y minus 2 quantity squared over 9 is equal to 1. As we have in the past, we're going to skip the parametric forms for conic sections. So we're going to skip G and H, and we're going to move on to taking the general form and writing it in standard form. And the way this works is the same way that it works for the ellipse. We're going to have to complete the square and put it in standard form. So I'm going to show you how to do I, and then you're going to do J on your own and check your answer. So let's group all the x terms together. So 3x squared minus 12x. Group all the y terms together. Minus 5y squared plus 30y. And put the constant 42 on the other side of the equation. You cannot complete the square until the leading coefficient is 1, so we're going to factor a 3 out of the x terms, x squared minus 4x. Remember, half of the x coefficient squared, so half of -4 is -2. Square that, we've got +4. Factor out a -5 out of the y term, so y squared minus 6y, and half of -6 squared is going to be +9. That is equal to -42 plus 3, and the 4 get multiplied, so we're effectively adding 12 to that side, so we had to add 12 to the other side. -5 and 9 get multiplied, so we're effectively adding -45 to both sides. We now have this term inside parentheses as a perfect square, x minus 2 quantity squared. We have this term for y inside parentheses as a perfect square, y minus 3 quantity squared. And on the right hand side, all of these terms add up to -75. So we have a -75 over here. So the last step is we're going to divide both sides, each term, by -75. So we get 1 on the right hand side. And when you do this, pay attention to the minus sign, because you're going to end up with the following: a negative x minus 2 quantity squared over 25 plus a y minus 3 over 15 is equal to 1, which we would typically change the order of and write it with the positive term first. So y minus 3 squared over 15 minus x minus 2 squared over 25 is equal to 1. So we can see that we have a hyperbola with center 2, 3, and it opens up, down. I'd like you to pause the video, do letter J, and then when you're finished with that, start the second homework assignment from hyperbolas. So just like we always do, we group the x and y terms together. We move the constant over to the other side, and we factor out any leading coefficients for the x squared and y squared terms. And when we do that and complete the square, we will end up with this line right there. We have to divide each term by 128 to get it into standard form, and when we get to the line after that right there, we have to simplify the 4 and the 128, and 128 divided by 4 is 32. So the final answer is x minus 4 quantity squared over 32 plus y plus 8 quantity squared over 128. And from that we can see we have a center at 4, -8, and this opens in a left-right direction, and the distance from the center to the point on the hyperbola is the square root of 32, and the distance from the center to the endpoints of the conjugate axis are the square root of 128. So at this point you should start the second homework assignment from hyperbolas.